fuel treatment planning. Here is your mission. You are a week into your new job at the Grand Canyon National Park, and you have been inspired by what you've learned about the North Rim Slopes Project. You've been asked to develop some justification for acres that have been treated on the project by comparing the fire behavior without fuel treatment, or no treatment alternative, to the fire behavior with fuel treatment, or the treatment alternative. To begin, you've been informed by Tessa Nicolay, the regional fire ecologist, that there are some initial adjustments of the land fire data that need to occur. Here's a little side note on fire and fuel modeling so that you can have a better idea about what we'll be getting into. So we're about to justify the existence of a really large and expensive fuel reduction project on the output of some fire behavior models. There is a lot to learn about fire and fuel modeling to make them the most effective, but sadly, that is not the scope of this course. What you do need to know is 1. Fire behavior predictions rely heavily on the inputted fire behavior fuel models, and 2. The fire behavior fuel models are more about how the fuel will burn and less about what is present on the site. This means that by visually assessing fuel model without experience on the ground of how that area could burn, the wrong fuel model could be selected, and in some places, the fuel model may change depending on the time of year. So the moral of the story is to always consult local experts when working with fuel models, and remember how much of an impact they have on your fire behavior output, and consequently the perceived success of your project. So let's get back to what we were working on in Lab 3. Here we have our project area on the North Rim, and I'm going to add one of the layers that I downloaded from Landfire. So here's my land fire layer. Notice it covers a very large area, crosses the canyon. Now if I kept all of this information, it would likely increase the processing time for the things that I'm going to be doing in this lab. So the first thing I want to do is I want to trim it to the area that I'm more interested in. To do that, I need to create a new polygon. So I'm going to go into my art catalog and into my Grand Canyon data, or into my lesson folder for lesson 4, and I'm going to create a new geodatabase for the Grand Canyon North Rim. So to do that, you right click, new, file geodatabase. I've done that here, labeled it the Grand Canyon North Rim, and in that folder you would right click, click new, and new feature class. And I'll make another one of these. And you're going to label your new feature class Grand Canyon North Rim. And I'll label mine 1, since I have one already. You're going to want to make sure this is in the proper projection. So it might come up with something that's in zone 11. If it doesn't have zone 12 listed here as an option, you're going to want to add a coordinate system. So you click this world and you would import. And to import, you just find any other layer that has the proper coordinate system. So for me, I would navigate to something on the Grand Canyon, just click any one of these and click add, and it would then show up here and you'd be able to select it as your projection. Click next, and next, next, and finish. So just as before, we now have a blank shapefile that's created, and we're going to edit that. So we're going to leave it in our project for now. We'll edit it and make it have some features. We're going to need the editor toolbar. Close mine so I can show you how to find it. So from Customize, Toolbars, check the box for Editor, and you can add it to your taskbar this way. So from the Editor toolbar, we're going to start editing, and we're going to select our new feature class. So Grand Canyon North Rim 1 for me. Click OK. Now you see a couple of the options here become available. So I'm looking for the Create Features option in the editor toolbar, but I'm not seeing it. It looks like I have a little bit of an expansion that I can have here. I actually would like to see more of these, so I'm going to move my editor toolbar. I'm going to grab it, drag it down a little bit more. Now I can see all the features here, so I've got my Create Feature. With this on, I can now click on the layer that I'd like to edit, and my construction tools appear here. I'm going to select Polygon, and once I've selected Polygon, you'll notice that these other options in the editor toolbar become available. I'm going to be using the straight segment, and I'm going to zoom in toward my area a little bit. I'm going to use my plus sign, and I'm going to just start to trace along the edge of the north rim of the Grand Canyon. And also it follows generally along where the fires have occurred, but more importantly I'm looking for the north rim of the Grand Canyon. So what I'm going to do here is actually add my slopes layer from land fire just to give me better visual reference on where the edge of the Grand Canyon is. So I'm going to start my editing back to Polygon, straight segment. I'm just going to start from this corner here. Now when you click, you create a feature line. We're not looking for something that is, oops, I clicked the wrong one. We're not looking for something that is super precise, just something that's going to help trim our edge a little bit. So notice I'm going relatively quickly along, making sure not to cut things too short, so I'm erring on the side of into the canyon a little bit. And each of your polygons will look a little bit different, and that's just fine. Now when I get to the point where I need to move, I can just click on either my hand feature or your zoom feature, and then click back to your polygon and continue editing. And we are going to go around this whole feature here. I'm going to zoom out a little bit. And at this point, I'm going to just go straight up to the edge and then over, and I'm going to encompass as much of that Forest Service land as I downloaded from Landfire. Although it's outside of the park boundary, since we are going to be modeling for fire behavior, it might be interesting to see what kind of fire behavior we get outside of the park boundary. So I'm just going to double click here and end my polygon. And now when I zoom out, you can see the rough outline of the area that I created. So now I'm going to stop or save edits and stop editing. And notice that my Grand Canyon North Rim now has information on it, and I can use that for our next step. So the next thing we're going to be doing is clipping our rasters that we downloaded from Landfire to this polygon area. So we're going to begin just by setting up our geoprocessing environment like we'd done previously, so that we don't have to reselect the location where we'll be saving this information each time. So again, here on environments, I'm going to designate my workspace as my lesson 4 folder. And I've created a folder here called Landfire Data Clipped. And so what you can do to create a new folder is from here you can just select this new folder button and add your information. Now I can select that folder as my current workspace. And I'm going to make that the same for my Scratch workspace. And that's all I need to do for now. So I'll click OK. Now under Data Management in the toolbox, I'm going to select Raster and Raster Processing, and then Clip. And I'm going to select one of my Landfire layers. So you'll want to add all of your Landfire layers to the project at this point, and then systematically work through clipping each of them. My output extent is going to be the new polygon that I created. Now this is an important thing here. You're definitely going to want to check the box for Use Input Feature for clipping geometry. Otherwise it'll just make a square roughly around the area or the polygon that you entered. So it labels it something that's relatively meaningful, so we can keep the name the same. So the name of the original layer plus the word clip, and you can click OK. And our clipping has been successful. So we'll go back to here. And I'm going to turn my other layers off just so that I can see the outcome of my clip. And you can tell here that we have now a slope layer that's been trimmed to the area of the North Rim. So you can do this for all the rest of the Landfire layers that you have, clipping each one to the same extent, and you will have a combination then of files that you can use to create your LCP eventually, and that we can use to edit our fire behavior fuel models for future parts of the exercise. So the next thing we're going to do is combine rasters so that we can start to make some edits to the fuel models that are present on the site. To do this, I'm going to start a new project. So I'm going to click New Sheet here and blank. And I am not going to save my changes to lesson 3. A lot of what we'll be doing in this lab is just doing the creation of layers and editing layers, less about creating a savable project. You'll notice that a lot of the output that you're asked to deliver are just screen captures of the work that you're doing along the way. So the tool that we'll be working with right now is going to be used to combine the attributes from several rasters so that all the unique combinations are displayed. In this case, we're going to want to combine our treatment raster with any fuel attributes that are going to be affected. So based on what we've been told by local experts on the ground, the fuel model 122 or GS2, moderate load, dry climate, grass shrub, needs to be changed to 183, or TL3, moderate load conifer litter, for elevations greater than 1,700 meters. In order to do this, we need to know which cells are both fuel model 122 and greater than 1,700 meters. Therefore, we need to combine the fuel model and the elevation layers. So let's start first by adding those two layers. So here is our fuel models, and oops, I added the wrong one. So to start, we're going to add our 40 fire behavior fuel model layer and our elevation, or DEM. Now we're going to go to the spatial analyst and select combine. Under local, select combine. And our input rasters are going to be both of the ones we have in the project. And our output raster folder is going to be, you're going to create an output folder here. These are where you'll put files that you most likely won't need again, that we're just kind of creating this file to get to a different end. So create an output folder here, and then in your output folder, label this DEM and FBFM 40, and mine gets a 1 after it. And then click OK. So now we have a new raster layer. What you'll notice that's different about this one is that it has a column for both the DEM value and for the fire behavior fuel model 40 value, which is exactly what we're looking for. Now we're going to begin editing the attributes in the combined raster to reflect the treatments or calibration. In this case, calibration, and then in a little bit we'll do the treatments. So we're going to have our attribute table open, and we're going to add a field. Remember from previous exercises, we go to the table options here and add field. And we're going to label this field FBFM40 underscore corrected. And click OK. And now we're going to use our field calculator to insert some values. So start the field calculator, click yes here. The first thing we want to do is just make the values in this column the same as the ones in our original FBFM40 column. Click OK. So that moves the information directly across. Now we're going to make some selection. So we want to select the rows where the fuel model is 122 and the elevation is over 1,700 meters. So to do this, we're going to use the Select by Attributes tool, and we will say in areas where the fuel model equals 122 and the elevation is greater than or equal to 1,700 meters, and apply. And in a handy way, we now have all of the items selected that meet those two qualifications. So then in our FBFM40 corrected, we're going to go again to field calculator. Now remember, field calculator only gets applied to the things that are selected. So for all of those fuel models that are 122 and over 1,700 meters, we'd like to change the value to 183. So I'm just going to type in the number 183 here and click OK. So now all of these values have been changed to 183. which, according to the local experts, is a more accurate representation of what occurs on the ground. Now I'm going to go ahead and save this project, since the next step does occasionally cause Arc to crash. I'm going to save this as my lesson 4 project. So what we have now is a raster layer that has one column that has the corrected fire behavior fuel model layers in it. In order to use this for the landscape scale file that we need, we're going to need to pull that column out and make it its own individual raster layer. You're going to want to clear your selected features here. I've done that. If you don't clear your selected features, then when you create your next layer based on the column that you created, then it's just going to create a layer based on the cells that are highlighted. So to create our new layer from the column that we have added, we're going to go to Arc Toolbox, go to Spatial Analyst, select Reclass and Lookup, and choose your input raster that you've been working on. Select the value as your new column, and then navigate to your Outputs folder, and you're going to want to name this, so we're putting in the Outputs folder because there's some additional adjustment that needs to be done before it can be used in our LCP file, specifically changing the areas that have been burned. So we're going to save it here for now, label it FBFM40, and then CORR. We're not allowed to have more than 13 characters, so we'll keep that there. And then you can click OK. And our lookup was created successfully. And you'll notice that if you had not cleared your selection here, that you would end up with just a small smattering of features that were created. You just delete that and then try again. So here we have our new layer. And we can move on to the next step, which is to adjust for the fuel treatments or fires that have occurred within the last several years. So sometimes when starting a new process, I find that it increases my functionality if I do start a new project here. Just a blank map. And I'm going to add the layer that I had just created there, my Outputs folder. And the first thing I want to do is I want to change the symbology so that I can start to recognize which colors represent which fuel models, and when I make my changes for the fires that have occurred or the fuel treatments that have occurred, I can see that distinct color change between those layers. If you choose a random color mix like these ones here, then those are going to change every time, so try and pick a color ramp. I'm going to go with just brown for now. So this kind of shows you, obviously there's not a gradient of fuel model across the landscape, but this will give a little bit of a distinct color pattern, one that you can compare then with the fuel treatment file that you create in just a little bit. So now we're going to add another layer here. We're looking for our fire history layer. So back to our Grand Canyon data. Under Grand Canyon fire data, fire history, and the fire history layer, click Add. And we're looking for the events that have occurred on the north rim of the Grand Canyon from 2012 to 2015 that are greater than 2,000 acres in size. So opening this attribute table, we'll sort by year. And after clicking around for a little while, identified those fires as being the Galahad, Cannabownits, Thompson project, range project, and NR piles. Now that we have those created, we're going to create a new feature class in our fire history data set. So close this, go to Art Catalog, to our Grand Canyon data, and in fire history, create a new feature class for North Rim fires 2012 to 2015. And I'm going to label mine 1 since I have one already. Click Next and Finish. So again, we have a blank layer here. I'm going to remove that. Right click on our fire history, data, export, navigate to the new polygon that I created, and click Save. Yes. And yes, I want to add it to the map. I'm going to remove my fire history now so I can see that I have polygons of the areas that have been treated or burned within the last several years. Now I'm going to change my symbology so that I can see through this area. Pick a color that's visible. Black actually works fine. And at this point, you're going to be taking a screen capture of the work that you've created. So you would center it, use your snipping tool, so you can use your search box to find your snipping tool, create new, highlight the area, and then save it as a PNG or JPEG. I think either one would work fine. So create a folder, navigate to your project folder for this lesson, and save it there. And then when you're asked to insert that into your quiz, then do so. Minimize this for now. So each of these fires is a combination of different fuel models. And after they were burned or treated, the type of fuel on the ground changed, and in some cases this was enough to necessitate a change in fuel model. The most accurate way to determine how to change the fuel model would be to ground verify a significant number of points on the ground. But since that's time intensive and very expensive, it's common for just a generalization to be made on what was there and then choose the less active fuel model to replace it after the treatment. Do you think that this is a perfect system, or what do you think about the ways that this could lead to misconceptions of the actual effects of fuel treatments and fires on the ground? To keep things simple for this exercise, though, we are going to follow some general recommendations from Tessa Nicolay for some fuel model conversions in the burned or treated areas. The first one is changing fuel model 188 to 183, changing fuel model 183 to 181, and then changing fuel model 165 to 161. If those numbers mean nothing to you, then you are a normal person, and so let's learn a little bit about those numbers so that we can have some reference for how we're changing things on the ground. So you're going to go to Scott and Bergen 2005 and read up a little bit about what those fuel models mean. So here's the publication, and we can scroll down. If you have a hard copy of this, it might be a little bit easier. This will work for now. So we're going to find one of our fuel models. We're going to look for 165. So notice that there's a letter designator with GR2, and then there's the number designator, and then there's the name. In GIS, it's easiest to work with the number because everything's working in numerics. So let's go to our 165. So 165 is a TU5, which is a very high load, dry climate timber shrub. And the question that you're asked for each of these fuel models is what the highest flame length is for the very low fuel moisture conditions. So for this one, the highest flame length is going to be roughly 16. So you're looking for just a general category here of what that flame length would be for very low fuel moisture conditions. Other ones you'll notice plateau. They hit a certain point and level off. And so what you're looking at here is, based on mathematical models, how we expect these different combinations of fuel to burn. And then using these inputted fire behavior fuel models, we were able to get what we might think would happen across a landscape with fire. So it's important to make sure that you are understanding what these fuel models are that you're changing. Going back to ARC, we're going to start on our next phase, which is to convert a polygon to a raster. In order to change the fuel models for just the area that were treated or burned, we'll need to convert our fire polygons into a raster. So under the conversion tools, you're going to select to raster and feature to raster. We're going to make sure that we've got our North Rim fires as our input and our fire name as the field. And we're going to select our output location as our outputs folder, and we'll label this North Rim 2012 to 2015. I'll label mine too since I have a couple already. Change my output cell size to 30. Click OK. So now we have a raster created for these areas. Next, we're going to be using this raster to adjust the fuel model values in this area. So similar to what we've done before with our raster calculator, we're going to be just using the ArcFuels tool. The reason that we weren't able to use the ArcFuels tool before was because we had the specification of elevation, which is something that at this point is not able to be done with ArcFuels. So we're going to select our corrected fuel model layer as the input, and we're going to add a series of directions here. We're going to start with changing 165 and replace that with 161. And each time we do this, we'll add it to the list. We'll be changing 183 to 181 and add that to the list. And then we'll be changing 188 to 183. Now you should know from your work with looking at those fuel models that each of these reductions was a reduction in the fuel loading and a reduction in the fire behavior, more importantly. Now, as to where these changes are going to be applied, we're going to apply them to the selected pixels in a raster and have that be the new raster that we created. We're going to keep this extent of the layer to modify the same. That's going to make it the whole extent of the input layer. And we're going to specify our target folder. Now this is going to be the file that we will use in our LCP, so we're going to put this in with the other land fire layers that we have clipped. So I'm going to call this, so in this folder, we'll call this FBFM 40 underscore ADJ for adjusted and 15 for 2015. So then click Create Raster and close. And here's our new raster with the corrected FPFM40. So now we'd like to display this so that it looks the same to our previous one. So notice that it's hard to compare. I'm actually going to turn off my raster here. Hard to compare what actually occurred. So to change this so that they do look the same, notice that I don't have the option for attributes table here. I'm going to go to my properties and I'm going to select unique values, and it asks raster attribute table doesn't exist. Do you want to build an attribute table? Yes. So it builds one for me and it adds those values, and I'm going to select the same color ramp that I had before, just my brown. Click OK. And now, so I'm going to pull my north rim layer to the top here. If I go back and forth between these, I can see that there has been a change on the ground that you can see from this change in fuel model. So your next question here is to again take a screen capture of this area and save it. Make sure that you label your pictures properly so you can find them when you need them, and then we'll be able to see that you were able to make that change. So now we're going to start in on developing a no treatment alternative. So we do this because we need to understand what the fire behavior on an area might be like before treatment was applied, so that then we can compare that to what the fire behavior is after the treatment gets applied. So again, I'm going to start a blank map. We don't need to save what we've done. We have the layers that we need. And I'm going to add all the land fire layers that were clipped, and we're going to start by building our LCP file. So navigate to your clipped land fire layers. And if you have had a couple iterations of this, you might have some files that you need to make sure you select the right ones for. So again, for your FPFM40, I think I might have added my original FPFM40. Yeah, I'm going to go ahead and remove this one. Oops. They were all selected still. So I'll remove my original FPFM40 layer since we have corrected that now. And we should have all the layers that we need to create an LCP file. So we'll go to Build LCP, using raster data. Now at this point I should mention that I will be working off of the directions from the ARC Fuels tutorial. We're doing this because it's important to become familiar with the different types of tutorials that are created, and if you want to use ARC Fuels for different types of projects, then it's best to become familiar with the way that this information is presented. So we are building the no treatment alternative LCP with raster only data and simulating fire behavior metrics. So here's the section for that, and we can click this arrow to do the exercise. So following these directions, we're going to be building LCP with raster data, and we'll be simulating these inputs in our simulation as well. So we'll go back here. Our elevation layer is going to be our DEM, add our slope layer and aspect. Fuel model, we'll use our adjusted fuel model, and canopy cover, canopy height, canopy base height, and canopy bulk density. And we'll check all the units based on what we're seeing on the land fire page. We've got meters, degrees, azimuth, percent, meters, kilograms, and all those match up. And then for output, we will check the box for default and save our output location. And we're going to save this LCP file to our, right now it's saving to our ArcFuels output. We're going to save this to our lesson 4 output. And we'll label it LCP corrected 2015. So that means that we've corrected the base information and the fire events up to 2015. And click Build LCP. Successful, total 22 seconds, and now we can click Close. So now that we have this LCP created, we can start to run some fire behavior metrics. For now, we're going to go back to our ARC project, actually a new ARC project, and go through our treatment alternative options. So to begin, we're going to add several layers, starting with the burn severity entries. And the Grand Canyon fire data, burn severity, and entries, and click Add. So now we're going to add our slopes completed file that we created in fire history, slopes completed, and also our adjusted fuel model layer. And for me, this one is in my lesson folder under land fire clipped. So what we're doing now is we have this project that's been completed, and similarly to how we updated our fuel models based on previous fire events, we're going to update our fuel models based on this project. So I'm going to zoom into my North Rim area, and as you can see, for our burn severity entries, we'll open up the attributes table just to see what it looks like. And you can see the name of the fire, the type of fire it was, and the severity class. And based on what we have learned from the slopes project, there are several severities across the site, and those change the fuel model in a predictable way. There's a document that's available for you on BB Learn called Fuels in the Slopes Unit, and this describes the way that those fuel models changed and has some pictures associated with them, which is helpful just again in getting reference to the area. So here we have pre-fire is 183, post-fire is 181, or non-burnable. For moderate to high severity classes, 183 also changed to 181, and occasionally 183. And low severity stays at the same severity or the same fuel model just because there wasn't enough to necessitate a change in fuel model, but as you can see there was some consumption of the fuel there, which would change fire behavior for a short amount of time. In this estimate, they're saying that it would expect to be a TL3 for the first year and 5 years post-fire. And then here for low severity areas, again, 165 stayed at 165. And here for our moderate to low severity areas, they're expecting a 165 to change to a 183 for the first 5 years. So that information, we can go back to our ARC project, and as we had done before, we'll need to use the tool option to modify raster values. But in order to modify those raster values, we need to have distinct inputs that tell the program which cells to modify and how. Because we have two different categories of modification that we're going to be doing, we're going to need to make two different layers. So in preparation for modifying our raster values, we will need to pull out the information specific to the slopes units. So let's sort here first. And find our slopes fires. Now, one thing that you'll notice is that we have several different rows for the slopes units, depending on the severity class. And according to the information from the ground, there are two different adjustments that we're going to make. So the first adjustment that we're going to make is going to be to the high slopes areas and the moderate high. So both of those we're going to convert from a 183 to a 181. So anywhere in those, if there's a 183, then it'll be converted to a 181. The second change that we'll be making are to moderate low severity areas. So in order to do this, instead of making all the slopes one file that have a variety of different severities, we're going to be making several files that are both from the slopes project and have one or at least one type of severity change. This is so that we can make that change happen with our ArcFuels tool. So I'm going to select my high fire areas and my moderate high fire areas. With these selected, now I'm going to want to change this information into a raster. One reason for this is that you'll notice if I zoom in here on these areas and I turn off my slopes completed project, that the burn severity is actually a polygon. Although it's in grids, it was converted from a raster to a polygon for some other purpose, and so now we're essentially going to be converting it back into that raster format so that we can do our calculation. So in the ARC toolbox, you're going to go to Conversion Tools and to Raster, and then Feature to Raster. And your input field is going to be your burn severity entries. And our field name is going to be severity. Now, for our output, instead of making it a part of the feature class as we've done before, we are just going to be saving it to our outputs folder. And we'll be calling it slopes 14 for 2014, and I'm going to call it HM for high and moderate, and click Save. And I'm going to change my output cell size to 30 and click OK. Now I got an error message here, so I'm going to check out what happened. I'll go to my geoprocessing results and see why that didn't process. Background server threw an exception. Usually when I get this error message, if I try it again, then it seems to work. So let's try that again. I'll go to Feature to Raster, Input, Burn Severity Entries, Severity, and notice that it didn't create anything, so I can use that same name. And we'll click OK. And I get a warning about my ARC license, which is fine. and that time it processed successfully. I'm going to go to my table of contents, and here is my new layer. So this has the combinations of high and moderate high burn severity. It shows me how many cells are in each of those categories. I'm going to go back to my severity entries, open this, again, scroll to my slopes project, and clear my selection and change my selection to the moderate low burn severity. And then in the ARC toolbox, feature to raster, set up my burn severity entries, severity, outputs folder, label this slopes 1-4 moderate low, and cell size of 30. Click OK. And that one created successfully also. Close this out, table of contents. Now I have the two layers that I'm going to need to make my adjustments to my current fire behavior fuel model layer. So again, back at the ARC toolbox, we're going to modify our raster values, and we're going to modify the FBFM40 adjusted for 2015. And for our first one, so we're going to be applying this to the slopes high moderate. And if you recall from the document, the request was to change 183 to 181. And those features can be the same. And in our class folder, lesson 4, I'm going to save this information in the outputs folder. I'm actually going to make a new folder for these slopes adjustments. For the slopes files. In my lesson 4 folder, I'm actually going to make a new folder for my slopes files and use that as the folder for my output for now. And I'm going to label this FBFM40, and this will be high moderate. And remember, we're going to be making another adjustment to this before it's our final raster layer. So we'll create the raster for now. So this raster's been created that has these adjustments made. And we'll go back to the tools, and we're going to modify the raster that we just created. And again, based on the information from the document, we're going to be changing 165 to 183 in the moderate low severity areas. Add that to the list. Target folder. Is going to be this slopes folder. And this is going to be the final raster that we use. So I'm going to label this FBFM 40 SL14. So that's going to tell me that it's from the slopes 2014 information. Alright, now our raster's been created, and here it is. One thing you might notice at this point in the project is that you are getting a lot of extra files that you don't need. I'm going to take a moment just to do a little bit of cleanup. So you'll notice that in my Lesson 4 folder, I had created a new folder, but it's not showing up yet. Art Catalog takes a little while to refresh, so unless you're closing and opening a project, it might not see the changes you've just recently made. So you may need to right-click on the folder and click Refresh. And now I can see that. So in this slopes folder, I'm not going to be needing this FBFM40HM, so I'm going to move that to my outputs folder. Eventually, I might delete the things that are in here. These are the temporary files that I might not need, but not until I'm fully done with my project. So now in the slopes folder, I just have one file, and I might look around here. This was an extra file folder for me, and so I'm going to delete that. Just cleaning things up a little bit. In my Landfire data clipped, I made the mistake of not clipping it directly around the polygon a couple times, so I might remove a couple of those duplicates. This is one of them. So of course never delete anything until you're sure that you aren't going to need it anymore, but it might be a good idea just to clean things up if you know that you don't need something. Alright, so one reason I did that now is that we're going to be moving on again to creating another LCP file, and so that we can more easily find the things we're looking for, and then we'll do another FlyMap run. So again, go to add your data, and you're going to be wanting to add, actually first we're going to remove the data that we're not going to need from this project. We can either start a new project or you can remove what you don't need here. So we have our new fire behavior fuel model. We're going to go to our Landfire data, clipped, and add the rest of the pieces we need, except for the fire behavior fuel model. Click Add. And I'm going to build this LCP using raster data. Oops. And our outputs, I'm going to specify the location of mine to that slopes project folder I just created. And label this slopes 2014 and build LCP. Click OK and close. So the next step in this process is going to be to again adjust this fire behavioral fuel model layer to reflect changes that we might anticipate seeing if we were to complete the rest of the slopes project. So the first thing we'll do is add the pieces of our LCP file. And I'm going to add the layer that we created for our target areas. And It's in my Grand Canyon folder under the slopes project, and the target area is 2015. So I'm going to zoom out. Because these areas haven't burned, obviously we don't know what the fire severity is, and we aren't going to be able to use that as a basis for changing these fuel models. So instead we're going to make a generalization about how the fuel models might change based on what we observed before. So the first step in this process is going to be to make this target area as a raster so that we can select that as an area for change. So we'll go to our ARC toolbox, and again under conversion tools, select features to raster. Now we will add our target areas as our input feature, and we'll leave the field at target, and our output raster is going to be saved to our outputs folder. Call it target areas 2015. Save. Oh, too long. (2015) and cell size of 30. Click OK. And it's taking a little longer than I expected, so I'll check my geoprocessing area. Looks like it's still working. Oh, there it goes. Successfully. All right, now we can go again to our tools, modify raster values, select our most recent fuel model layer, and again, since we're doing a generalization across the landscape, we're going to say that the change that we expect to see is from fuel model 183 to 181. And the other fuel model change we might expect to see is from 165 to 183. Now the assumption that we make here, of course, is that in our previous exercise where we changed based on fire severity, now we're changing across the board for the area. So areas that might burn moderately might see this change of 165 to 183, but then it's also going to be applied to other areas that might not burn moderately, either they'd burn lower or higher. So we are going to make some assumptions here, but that is what we do when we are modeling what might happen in the future. So we'll put our target area, target 2015, as our selected pixels, and save our output. And I'm going to save this also in the slopes folder, and label it FB FM 40 and target. Let's see if that works. All right, let's see what we made here. It is down at the bottom, so I'm going to press Control, uncheck all of these, and minimize them all. And I will check on my FBFM 40 layer here. And there it is. Okay, so that is our potential future fuel model layer. So as a final step, we're going to build our last LCP using raster data. And we'll input each of the layers needed. Slope, aspect, our new FBFM 40 target layer, and canopy height, canopy base height, and canopy bulk density. And on outputs, choose the location of our output. I'm going to put this in the slopes folder, and I will call it slopes target areas, and save, and then build our LCP. And successful. Close. There's one small final task that you need to do in order to complete this exercise, and that is to make a little bit of preparation for next week's exercise. We're going to go to the folder for this class, and in the lesson 5 folder you're going to make a new folder here for inputs. And from our lesson 4 folder, you're going to locate the 3 LCP files that you generated. I'm going to copy these out and then bring them into the lesson 5 folder. And then there's one more that I'd saved into the outputs folder. I'm also going to copy this fuel moisture file over that you will have access to next time. Copy this, and lesson 5. So then your last question is to take a screen capture of this. So going to our snipping tool, you're going to copy this folder structure. Try to include the header above so we can see the file path, and then that shows us that you've created 3 LCP files. You're not going to have the fuel moisture file in there, so that's fine. If the names are slightly different, that's just fine as well. And mainly we just want to make sure that you're going to be prepared for next week's lab.